It's Don here from the board. Thanks for coming along and checking out this video. So you would have seen possibly part 1 and part 2 of the mini-lathe series. The first one was just the unboxing, and then the second one was when I actually attempted to turn something and it did not go according to plan. So that was quite a bit of a disaster. Now this is part 3 because I've already gone through and done some upgrades of sorts. I've bought some extra bits and pieces and I've had another go at turning. I just want to keep talking my way through that journey to end up with a rotary encoder knob. So let's switch down over the desktop and walk through where this journey has got me so far. Okay, so here is the mini lathe with the sort of drill style chuck jaw with a chuck turning tool, and here is the disaster that I tried to turn last time, which was a bunch of paddle pop sticks or craft sticks that had been glued together with PVA wood glue, and I was trying to cut through the grain and it was actually peeling chunks off it. It wasn't cutting the way that it should have been. So some of the issues are the fact that the original mandrel that came with it, which was this little thing, was just terrible at doing what it needed to do. So the first thing that I went and did was I went and bought a proper whatever you want to call this. Is it a Morse taper, I think is what it's called. The Chinese listings for this on places like AliExpress and Banggood and stuff like that called it a flower taper. But either way, it's something that actually provides proper grip into the piece that you're turning. And what that does is it just fits into the actual chuck and you can tighten it down and it'll hold your workpiece properly. Now, what happened was I took that off because that wasn't really serving anything. That's designed for, you know, an actual cutting blade if I was going to fit one there. So that's okay. It wasn't really doing very much. And I went and invested in some proper tools. So I was trying to use wood carving tools, the tiny little ones, and they weren't really up to scratch. They just would not do what I needed them to do. So I went and bought a set. This is a big set and it's really cheap. This was $40. This was $40. Locally in Australia, you wouldn't even be able to buy one of these for $40. But I was able to get an entire set. Now, they're not fantastic quality, I don't think. The steel on them doesn't seem to be super duper awesome, but they were sharp enough to do something. But I got this entire set for $40 online via AliExpress. So I can't complain, right? So I got that. And then I needed an actual proper timber to work with. This is where I hit the next problem. My parents have a really extensive garden. So I thought I'd go there and just get a bit of branch that they'd already cut down, and it was just sitting there in their sort of green scraps pile that they use for, you know, composting, covering, ground cover, stakes to grow plants against and all that kind of stuff. And I grabbed a stick. Hang on a moment. Right, so I grabbed one, right? It was this thing. And I cut a section off the end of it, right? So there's the nice smooth cut that I cut with a handsaw, and I tried to turn it. The problem was it was not turning. I was running it at about 6 volts. This motor is meant to run up to 24 volts. So I was running on 6 volts and it wasn't doing the job. And I was getting really frustrated because it just kept stalling and it wasn't doing what it needed to do. And I took a bit of time. I went and did a bit more reading and whatnot about cutting stuff. And the only real solution I thought was let's just go up in speed. So I took it to 12 volts and then it started to cut. And the tool started to work and everything else was really hunky-dory. So this is what I ended up playing around with and shaving down. And you can see I've marked the center. The actual taper tool has got these cuts in it that actually form. You can kind of see well, it's very bright, but there's these little dents which the tool helps grip into, which is great. And then on this side, it's just the center bit there that this pointy bit here freely spins around, right, to support that as the tailstock. So using those really cheap lathe tools, those hand chisels, I was able to actually peel off the bark. I was able to smooth it and cut these ridges, and I was just experimenting. I was just playing around and learning, how to make those cuts and make those activities occur. But I was still really struggling because it was quite difficult to do that on this, and it kept stalling a lot. So I was like, I think this is a hardwood. And I don't think this is designed for hardwoods. It doesn't have the torque and the oomph behind it. So I went and did my research, but my problem was I didn't know what this was. I went back to my parents and I said to my dad, do you know what it came from? And we went having a look through all the trees, through the fruit trees, and we think this is from the pomelo tree. And pomelos being citrus, and citrus produces hardwoods. So that was a really big mistake. Now, if you're a beginner wood turner, especially if you're using something that's like tiny like this and doesn't have a lot of power behind it, don't start with a hardwood. Go get some softwood. Now, somebody locally said, just go to the hardware store and get some pine doweling and do that. And yes, I could do that, but I don't want to do that because I don't want to spend the money to go and get a meter length of pine doweling. Yeah, I know it's $10. It's the principle of the matter. I got free timber at my parents' place because I'm like that. So I said to my dad, what do you think we've got here that is softwood? So now I have this little bit that I hacked off, and we think it's from a fig tree. And the density of this, the weight of this is much, much lighter. So I can kind of like score it a little bit with my fingernails. So I think it might be softwood, but I haven't tried to turn this yet. So that's the next step, is I'm going to probably cut this down a little bit so it's a shorter length, so I'm not working with the full length of it, and give it a try. However, some of the issues that I've got with going forwards is, once I turn this to my satisfaction, I still need to be able to hollow it out to fit it onto the encoder. And in order to do that, I need a means of being able to drill down it. Now, I don't have a drill press that's really suitable. So the option is to use a tailstock that allows you to attach pieces to go into it. And on the other side is you're going to need a chuck, a jaw chuck, to actually be able to hold the workpiece, unless if you want to have your marks on that, right? Which, is not desirable for your end product. So what I've done is I've purchased a 3-jaw chuck. So there's the 3-jaw chuck. And theoretically, the 3-jaw chuck should... I haven't tried this, so this is literally the first time I've tried this. There you go. It's huge. Will fit into this and hold your workpiece, right? And now it's got these two little metal pins that you use to open and close the jaw, so you can actually clamp your workpiece into it, and therefore it won't need the actual Morse taper on it to spin it. So that's problem solved. But then on this side, I still need the tailstock to be able to drill or cut a hole into the end of that. And well, the problem is the actual size of this spindle holder and this bearing isn't even standard. It's not even universal. It won't even fit some of the other things that are going into it. So I had to get something else that was different, which I ended up getting this. Now, this this main section here, ignore that, because that's just a it's just another piece that comes off. This allows you to attach drill bits into it, or a free rotating tailstock pin, just like this, or I do have it somewhere. If you need to, for whatever reason, you can also attach another free spinning Morse taper in it if you want to ensure that you've got a lot of grip on whatever piece is actually spinning around. So that's quite flexible, but the thing is this piece doesn't actually turn. It doesn't spin, which is why that end piece actually has a bearing in it, so that will spin because this won't. Because obviously if it spins as it spins with your workpiece, you're not going to do any cutting once you put your drill bit in. But you undo that and you can actually extend it. So it's got about 4 centimeters of extension, so that allows you to actually plunge your drill bit into your workpiece. However, what I discovered too late, because I hadn't done my research properly, is that the gap of those mounting points don't fit this rail. It's the wrong size. So I had to 3D measure and design this adapter block so that I could slide it into the block and these will sit into the rails and then it will lock down. So that will come off and then that will slide on just like that. And then I can screw it down to lock it. And then that will allow me to have my drill bits and extend and so on and so forth. But now the problem is, because I'm adding all this extra stuff and the drill bit's still got to go on the end of it, I've gone from a big bed to I can barely do anything because I can't fit a short drill bit into that and extend it. It just won't work. So I've had to go out and then I sourced another piece, which is a bed extension. So there's a 600mm bed extension, which I haven't fit yet, but what that will allow me to do is I'm assuming that my ordering has been correct, but it should be the same size tracks, and if it isn't, I'm going to scream with much frustration. But this will now give me as much workspace as I require, because if I have a good length of drill bit, just a standard bog drill bit, then I can move it in as close or as long as required. So that is the journey so far. It's a very long journey and not a very cheap journey for that matter, but my setup now allows me to have a 3-jaw chuck. I might need to get a 4-jaw chuck if I'm working with square pieces, because square pieces don't fit very well into a 3-jaw, but round pieces work in that fine. And if I need to do slightly larger pieces with tenons, then I can also do that. It gives me this tailstock that allows me to move it and cut and also hold pieces with these extra bits and pieces that I've added. The only solution thing that I still need to work on right now is this tool rest. This tool rest is very limited because it's only very short, and when you work on bigger pieces, it's actually too low. So when that's actually mounted, the height of that tool rest is way too low for what it needs to be. So I'm just going to show you what I mean by that. I'm just going to tighten that down. If I flip that over, the tool rest is too low. I need to be able to move that higher or lower to accommodate for the different sizes of pieces and diameters that I'm working at. It's fine if you're working for something that's very small because it is centered to that center line, but it doesn't work very well when you've got larger pieces. I don't have a solution for that yet. I might need to 3D print something. I might need to try and get an angle that's just a bit bigger and have a slot cut into it. Haven't quite got around that yet, but it's not as important because despite having bigger pieces, I can work at an angle that's not so comfortable, but it's still doable for what it is. So there you have it. That is all of the progress so far with the mini lathe and everything that I've learnt and discovered on what this is capable of doing and how I'm doing it, and also my own mistake of picking a hardwood to start with. So when I get a bit of time, maybe this weekend, I will move things around and then try and cut this softwood and see what that looks like to end up with a hand-turned encoder knob. Still might be a way away from that, but we'll see. Oh, the other thing is, because this piece is actually wider, this housing will not fit, will not clamp onto that. So I may have to electrically disconnect the switch. And well, I don't use the power port as it is anyway, because I'm clamping straight onto the motor. But I do use that as a emergency switch cutoff situation. So I clamp positive straight to the motor and then the negative to the actual switch, so that's acting just as a straight off switch. But that's just another thing to deal with. Yeah. But overall, it's fun. I had a really good time taking the bark off this and just learning using the tools to shape and cut and shave and peel. So yeah, hopefully I'll be able to continue to have fun with this. So that's it. Now, if you do want to, of course, check it out yourself and whatnot, probably have links to it below, or you can check out the previous videos, which will have link to this as well. Okay, right, thank you very much for coming along and checking out this video as usual, and hit that like button, subscribe button, bell notification button, all that kind of stuff if you want to see and keep up with how this turns out and all the other crazy wacky stuff that I do and build. And yeah, we'll see you on the next one. So of course, as usual, until next time, happy clacking.